Hello, good day everyone. Today we will learn about seismic waves. Seismic waves are vibration or energy that travels from its point of origin inside the earth in all directions. Suppose an earthquake has occurred here, then the waves will travel in all directions and eventually reach the surface of the earth. These are caused by sudden movement of material inside the earth. Most of the seismic waves are created due to movement of lithospheric plates inside the earth, but some can also be caused due to volcanic eruption, magma movement or magma intrusion, or man-made causes like violent explosion. Seismic waves are classified into two types: body waves and surface waves. Body waves are called so because they travel through the body of the earth, whereas surface waves can be found only on the surface of the earth. Body waves are further classified into primary waves or P waves and secondary or S waves. Surface waves are classified into love wave and Rayleigh wave. Primary waves are called so because they are the first to reach at the seismograph because their velocity is highest. Seismograph is an instrument which is used to measure the magnitude of the earthquake, and we can also find out the time at which different types of waves occur at a seismograph. P waves propagate through the medium by squeezing and stretching it. Look at the black dot in the middle. It is being squeezed and stretched. And this is how this wave propagates. That's why it is also known as compressional wave. And since it creates region of high and low pressure, it is also known as pressure wave. And because the particle motion is along the direction of propagation of the wave, that is, if the wave is propagating in the x direction, the particles in the medium, they are also moving in the same x direction. That's why it is also a longitudinal. Its velocity depends on rigidity of the material and non-compressibility. If it is compressed easily, then through that medium, velocity of the P wave will be less. Secondary waves or S wave arrive at the seismograph after the P waves because its velocity is less than the P waves, and they are transverse wave. Transverse because the vibration of the medium happens perpendicular to the direction of propagation. See this one, like this. The black dot is being vibrated in the z axis. while the wave is moving along the x-axis. This is also called shear wave because this type of movement is known as shear, and it travels only through solid medium. It does not travel through liquid mediums because liquids do not have the ability to shear. Its velocity will also be higher in rigid medium, solid mediums, and will be completely absent in liquid medium. When body waves interact with the surface rocks, then surface waves are produced. These have low frequency but high wavelength and high amplitude waves, which are present only at the surface. And as we move from the surface to the interior of Earth increasingly, its amplitude started to decrease in an exponential manner. It has two types, love waves and Rayleigh waves. So love wave moves the medium or the ground side to side. So if the direction of propagation is on the x-axis, then on the surface you see this black dot. This is being moved side to side, left to right on the surface. It also causes a lot of destruction. The next wave, Rayleigh waves, which are more destructive than any of the waves which we have read because it vibrates the medium in a orbital fashion like this. Look at this. Let's recap a little bit. P waves, high frequency, high speed, but less amplitude. S waves, relatively more amplitude than the P waves, but its velocity is less. Then in the surface waves, love wave uh, has very high amplitude. Rayleigh waves, slightly lesser amplitude and velocity than the L wave, but very destructive because of the orbital motion or elliptical motion it causes in its medium. So velocity of P wave is highest, then S wave comes, and after that L wave, and finally Rayleigh waves. P waves velocity depends on rigidity and non-compressibility of the material, and hence solid rigid material are the best for the P wave to propagate. In liquids, its velocity decreases, but nonetheless it still travels. S wave, shear wave do not travel through liquid because liquids do not have the ability to shear, but it can travel in semi-molten or highly viscous liquids. But nonetheless, the velocity will be very feeble. The point of origin of the seismic wave or earthquake is known as focus, and the point directly above it on the Earth's surface is known as epicenter. With the help of seismometer, we will try to find out about the location of this epicenter. Suppose if I have a seismometer at a location A and it records the arrival of a P wave at 10 o'clock. This is the first P wave. And then after 5 minutes, the first S wave is recorded. And we know the velocity of both P and S wave. So we can write Velocity of P wave is equal to displacement or the distance in its vector form that it covered divided by Tp. Similarly, we can write it like this for S wave as well. We can rewrite these equations like Tp equal to d upon Vp and Ts equal to d upon Vs. We know, sorry, we know Ts minus Tp. It will be, if we take d common, 1 by Vs minus 1 by Vp. This is in our case is 5 minutes, that is 300 seconds. Now we can easily calculate this d. Suppose this whole term is 2 kilometer, the difference comes out to be 2 kilometer per second. So d will be 150 kilometer. So this is the distance between the seismometer A and the point from which earthquake has started. That is the focus. But for simplicity, we will say that some form of adjustment is done on this. This depth is adjusted, and then we use this as an this distance is the distance between the epicenter and the seismometer. So these adjustments can be made. Like if a triangle will be formed, this is the focus, this is the epicenter, and this is the seismometer. So this can be done. So for simplicity, let's say that the distance between epicenter and A comes out to be 150. But we do not know that this epicenter is in which direction. In this direction, in this direction, or in this direction. Thus all we can say that if we draw a circle with center A with radii 150 kilometer, then the epicenter will be somewhere on this circle. Thus with the help of one seismometer, all we can find out is the distance. So on a map, we plot the circle around location A. This is the location where A is, and with a radius of 150 kilometer, plot the circle. This is the actual location of point A on the map. Similarly, from another seismic station B, we found the distance to the epicenter is 200 kilometers, let's say. Uh, and it is located somewhere here. And this distance is 200. Thus, now we have 2 points, E1 and E2. Both can be the epicenters because this is the intersection point between these circles. But we don't know which one. So we will take another seismometer, let's say C. And from there, one of the points will be intersected. Let's say this is 30 kilometer. So the intersection point of these three circles drawn from three seismometers, we can find the exact location of the epicenter. This method is known as trial iteration. This is a more realistic example. Suppose three stations A, B, C, the distance are given 33, 900, and 1800 kilometers, and then they intersect at a point which is the epicenter. Look at this image. This is a typical picture of seismic waves that you will find in a book or on the internet. The lines in yellow and red are body waves that are moving through the interiors of the earth. But why are they curved and not traveling at a straight path? To explain this, I have to take you to the familiar light waves. You must have studied in your high school that when light moves into a medium where its velocity changes, its direction also changes. If its velocity increases, then it moves away from the normal, and if its velocity decreases, then it moves towards the normal. Another way you can understand this, that if its velocity increased, then it takes a path which is longer, and if its velocity decreases, then it takes a path which is shorter than the previous one. This is known as Snell's law, and seismic waves also follow similar behavior. That's why they are curved. Seismic waves are the most important source available to us to understand the layered structure of the Earth. How? We will see so. Beyond 103 degree of the epicenter, we do not find any direct S wave. Thus, it is only possible if the S wave is not able to penetrate from the mantle to the core. Thus, we can say that there must be a region from mantle to the core which is molten. As we know that S waves do not travel in molten or liquid mediums. Between 105 and 145 degree, the seismometers do not record any direct P waves. This is because when the P wave moves from mantle into the outer core, which is molten, its velocity decreases and hence it moves towards the normal. So instead of going like this and being found at one of these seismometers, it moves inward toward the normal, just like the light wave, because of decrease in velocity, and is later found somewhere between these 145 degrees. Thus, what we find by the S-wave cytozone is in a way confirmed by the P waves that the outer core is actually in a molten state. So I have a question for you. You just saw the behavior of the S wave. It does not move through liquid materials. So my question is, will there be presence of S wave in the inner core? Because we know that S wave does not penetrate the outer core, but the inner core which is solid. So will there be S wave in the inner core? Common sense says that when it could not enter into the outer core, how can it be found in the inner core? So we would say no, it won't be found. But unfortunately, the answer is yes. There will be some S waves in the inner core. When seismic waves travel from one velocity medium to a medium in which the velocity is different, three things happens. It gets reflected, it gets refracted, and it also does phase change. The P will convert into the S wave, S will also change into the P wave. So that's some P wave which will undergo phase change in the inner core to S wave. That's why S wave will be found here. And that is why it is written here that no direct S wave is received here because the P waves which gets converted into S wave will be found here. That is all for this video. Hope you learned something new and enjoyed it. If you have any further doubt, you can write in the comment section. Thank you so much.